you've touched steel in the last hour without noticing. A door hinge, a fork, a car door, the frame inside the building you're sitting in, and a ton of the stuff. 1,000 kilos of the strongest cheap material our species has ever made sells for a few $100s. That's roughly what people pay for a nice pair of headphones, except it's enough metal to build most of a small car. Steel is so ordinary, it's become invisible. It wasn't always like this. For most of human history, workable iron was rarer than gold, and the only reliable supply came from the sky. That's not a figure of speech. Before anyone could pull iron out of rock, people found it already made, in meteorites, which arrive as metal because they cooled that way in space. The ancient Egyptian word for iron translated to something close to metal of the sky, and the dagger buried with Tutankhamun around 3,300 years ago has a nickel signature that marks it as meteoric. The first iron blades weren't mined, they landed. The world before iron ran on bronze, and bronze had a problem hiding inside it. Bronze is copper mixed with a little tin, and those two metals almost never sit near each other in the ground. Tin came from far away, from Cornwall, from Central Asia, moved along trade routes that took months. So a bronze sword wasn't really a feat of metalwork, it was a feat of shipping. Whoever controlled the route controlled the weapons, which meant the strongest army was usually just the best connected one. Then, around 1200 BC, the routes went quiet. The Bronze Age civilizations came apart, cities burned, and the tin stopped arriving. Here's what made iron the replacement. Iron ore is almost everywhere. It's one of the most common elements in the Earth's crust, sitting in ordinary-looking rock across most of the inhabited world. The catch was heat. Iron melts far hotter than early furnaces could go, so nobody could pour it. Instead, they built a bloomery, heated the ore with charcoal until it went spongy rather than liquid, then beat the impurities out with a hammer for hours. Bronze cost you a trade network, iron cost you labor, and after the collapse, labor was the thing people still had. Now, who discovered steel? Nobody. There's no name and no year, and that's the most interesting part of the story. Steel is just iron with a trace of carbon in it, under 2%, often a tenth of that. And if you're smelting iron in a charcoal fire, carbon is already in the room. Steel showed up as a contamination that happened to be better than the thing people were trying to make. What followed was 2,500 years of craftsmen learning to control an ingredient they didn't know existed, judging it by the color of the glow, the sound of the hammer, the way a blade sprang back. They were baking bread for centuries before anyone knew what yeast was. Some of them got extraordinarily good at it. Wootz steel, made in southern India, was exported west and turned into blades with a watery pattern in the surface that Europe spent centuries failing to copy. Japanese swordsmiths folded Tamahagani steel to spread the carbon evenly through the blade. In Sheffield in the 1740s, a clockmaker named Benjamin Huntsman got fed up with springs that kept failing and worked out how to melt steel in sealed clay crucibles, which finally gave a consistent product. But every one of these was small batch. Steel came out in kilograms, iron came out in tons. Steel was jewelry scale, and that ceiling held for the entire pre-industrial world. The ceiling broke in 1856, with a move that sounds like a mistake. Henry Bessemer blew cold air straight through molten iron. Every instinct says that should chill the metal solid. Instead, the oxygen in the air found the excess carbon and burned it, and that burning threw off so much heat the iron got hotter on its own. The impurity was the fuel. A process that took days now took about 20 minutes, and the price of steel fell off a cliff, dropping by something like 80% while output multiplied. That single change is why the world looks the way it does. Cheap steel meant railways that didn't wear out under heavier trains, and ship hulls that could be bigger than any tree. It also broke the height limit on buildings. A stone building holds itself up with its walls, so the taller you go, the thicker the base has to be, until the ground floor is nearly solid rock and there's no room left for a lobby. A steel frame carries the weight instead, and the walls become curtains hung off the skeleton. Every skyline you've ever photographed is a side effect of that. And here's a smaller one. Steel let people mix it into concrete, where the concrete handles being squashed and the steel handles being pulled, which is why bridges span what they span. Andrew Carnegie became the richest man alive on the back of the process, and steel output turned into the number people used to measure whether a country counted. Though not everyone trusted it straight away. The Eiffel Tower went up in 1889 in the middle of the steel boom, and Gustav Eiffel built it out of wrought iron instead, because he'd rather use a material he could inspect than one whose quality still wandered from batch to batch. The most famous metal landmark on Earth is a vote of no confidence in the new stuff. Which brings us to now. The world makes roughly 2 billion tons of steel a year. China alone accounts for more than half and turns out more steel in a week than Britain, where the modern industry was born, now manages in a year. It's the most recycled material on the planet by weight, because you can melt an old car into a new beam without the metal caring. And yet steel has become one of the hardest things to clean up, for a reason that isn't about energy at all. Iron ore isn't iron. It's iron that's already grabbed onto oxygen, effectively rust, that formed a billion years ago. To get metal, you have to steal the oxygen off it, and for the last 2 centuries the thief has been carbon. Coke goes into the blast furnace, takes the oxygen, and leaves as carbon dioxide. That CO2 isn't a leak or an inefficiency you could engineer away. It's the intended product of the reaction, which is why steel accounts for somewhere around 7 or 8% of global emissions, and why you could run a steelworks entirely on solar power and still emit almost exactly as much. The chemistry is the emission, unless you change the thief. Hydrogen wants oxygen just as badly as carbon does, and when hydrogen takes it, what comes out of the stack is water vapor, steam. That's the whole idea behind hydrogen direct reduction, and it isn't theoretical. In Sweden, a project called Hybrid delivered the first steel made without fossil fuel in 2021 to a truck manufacturer. Small batch, expensive, real. The catch is that hydrogen has to be split out of water using electricity, and the amount needed to run a steel industry is enormous, which quietly redraws a map that's been fixed since Bessemer. For nearly 2 centuries, you built steelworks where the coal was, and the ore travelled to meet it. If the input becomes clean electricity, you build where the sunshine and the wind are, next to the ore, and ship metal instead of rock. Countries that currently export dirt could start exporting the processing, and countries that got rich on coking coal could find their advantage has simply evaporated. Steel's geography has always been decided by whatever was cheapest to burn next to the ore. Change the input, and the whole industry gets up and walks. So, the invisible metal in your door hinge turns out to be a fossil of every energy system we've ever used. Charcoal from a forest, then coal from a seam, and maybe next, water and a wire, which is worth carrying around with you. Because steel isn't the only thing shaped that way. Cement, glass, fertilizer, plastic, all of them are just frozen decisions about which fuel was cheapest at the time. So what else in your house looks permanent but is really only the leftover shape of an energy source we haven't finished replacing yet?